All right, let's dive into something that has been haunting physicists for 100 years. It's a question that sounds so simple, but it might just unravel everything we think we know about reality.
I mean, seriously, what happens? In our everyday lives, looking at your coffee cup doesn't change it, right? But down at the quantum level, the very foundation of our universe, well, that's where things get really, really weird.
And this is the heart of the whole mystery. The simple act of observing a quantum system, of measuring it, seems to fundamentally change it. And this isn't some tiny little quirk, you know? This is a deep philosophical crisis that has stumped the smartest people on the planet for a century.
So to really get what's going on, we first need to get our heads around something called the observer's paradox.
Okay, so before we look at a tiny particle, it's kind of like a spinning coin. It's not heads, it's not tails, it's both, all at once. Physicists call this superposition. But the moment we measure it, the moment we look, that spinning coin suddenly lands. It's heads or it's tails. That cloud of possibilities collapses into one single reality. And the crazy part? Our observation seems to be what forces it to pick a side.
And this is where the legendary physicist Edward Witten enters the picture. He argues that you just can't untangle this whole wave function collapse from the conscious observer who's actually doing the looking. So suddenly, this isn't just about math anymore. It's about consciousness itself.
Now, this philosophical challenge that Witten's pointing out isn't new. For decades, two massive theories have been battling it out over this very problem, proposed by two giants of physics, Niels Bohr and Hugh Everett.
Niels Bohr, one of the founding fathers of quantum mechanics, had let's just say, a very practical solution to this mind-bending problem. His advice was basically, don't worry about what it all means.
You see, Bohr wasn't trying to describe what reality is. He was just giving us a rulebook. He saw quantum mechanics as an amazing tool for making predictions, and that's it. It's been called a pragmatic evasion. Hey, it works, so let's just use it and not ask why. But then, Hugh Everett came along with a totally radical idea. He said, what if there is no collapse? What if instead, when you observe something, you become quantumly entangled with it? That means your fate and the particle's fate are now linked. You, the observer, actually become part of the system. And this just lays out the difference perfectly, doesn't it? Bohr hands you the rules to play a game, but he never actually shows you the game board. Everett, on the other hand, tries to describe the entire board, including you, the player. One just sidesteps the mystery, the other dives into it head first.
But here's the twist. According to Edward Witten, both of these brilliant, completely opposite theories, they fail. And unbelievably, they fail for the exact same reason.
Yeah, Witten looked at Bohr's shut up and calculate idea and Everett's grand explanation and was, let's just say, not impressed. He saw a deep, logical flaw at the core of both of them, a kind of intellectual black hole that neither one could escape.
And here it is. It's called the problem of infinite regress. Think about it. If an observer collapses the wave function, then what observes the observer to collapse their wave function? You'd need a meta-observer, right? And then what observes the meta-observer? A meta-meta-observer? You see the problem. It's a chain of observers that goes on forever. There's no final stop.
So, how did our two thinkers deal with this infinite chain? Well, Bohr just cut it off before it even started. He simply refused to answer the question. He escaped. Everett, by tangling the observer up with the system, didn't solve it either. He just kicked the can one step down the road. Now you have to measure the measurement device and so on. Bottom line, neither of them actually solved the puzzle.
This all leads us to a fascinating conclusion. I mean, what if this whole mystery feels unsolvable because we've been asking the wrong question all along? To get this, we need a cool idea called emergence. Think about a traffic jam. A single car can't be a traffic jam, right? The jam is a complex thing that emerges from the interactions of a bunch of simple parts, the cars. Consciousness is kind of like that, but with neurons.
And here is Witten's profound insight. What if the very idea of knowing something, of observing, is itself a fuzzy emergent concept? If that's true, and we're trying to build a fundamental theory of physics on top of that fuzzy idea, why would we ever expect to get a sharp, precise answer? It's like trying to build a skyscraper on a foundation made of fog.
This leads to a totally radical reframing of the entire problem, which comes from our source material. Maybe we've been looking at this completely backwards. Maybe we don't need an interpretation of quantum mechanics at all.
So think about it like this. Imagine reality has two layers. Layer 1 is the raw, fundamental stuff of the universe that we can't ever access directly. Quantum mechanics, then, is layer 2. It's not a perfect picture of reality, it is our interpretation of it. It's the language, the tool we've developed to try and make sense of that deeper layer.
And that leaves us with this final, really provocative question. By asking for an interpretation of quantum mechanics, are we basically asking for a map of the map? Have we been mistaking the tool we use to understand the world for the world itself? It's a thought that doesn't solve the mystery, no. But maybe, just maybe, it shows us that the mystery was in the question all along.